The title of the first section is Graphing, Exponential, Functions, and Domain/range. Exponential means the variable will be the exponent, and we'll find the domain and range, which, if you remember, is the same thing as the x values and y values. The first function that we'll graph is y equals 2 to the power of x. As with any new function we'll graph, first we will draw a t-table. You can use any numbers you want on t-tables, but with new graphs, the best numbers to use are -2, -1, 0, 1, and 2. This will give us some negative numbers, some positive numbers, and also the 0 value for x. The first number we'll plug in is -2 for the x value. That would be 2 to the -2nd. If you remember, with negative exponents, that means you put them on the bottom of the fraction and they become positive exponents. 2 squared would be 4. So our first answer, -2, would be 1/4. If you do the same thing for -1, 2 to the -1 power would be 1 over 2 to the first, or 1/2. You plug a 0 in, 2 to the 0 power. By definition, any number to the 0 power would just be 1. So we'd have 0, 1 as our point. 2 to the first power would just be 2, and 2 squared would be 4. Once you have your table of values, you can draw your xy axis. The first point, -2, 1/4. -1, 1/2. 0, 1, 1, 2. And 2, 4 would be up higher. If you connect the points, they'll kind of curve up, and the left side will go parallel to the x-axis. The next question we'll graph is y equals 2, parentheses 1/3 to the x power. Same steps as before. We'll do a t-table. Again, the best numbers to use will be -2, -1, 0, 1, and 2. Plugging the first number in, -2 for the x. We have 2, 1/3 to the -2 power. Again, negative exponents mean the fraction flips upside down. So instead of 1/3, this will be 3 over 1, or just 3. And the 2 will be a positive 2. 3 squared would be 9. And 2 times 9 would be 18 for our first y value. Next x is -1. So 2 times 1/3 to the -1 power. 1/3 again flips over with the negative exponent. 3 to the first power would be 3, And we're left with 2 times 3, which should be 6. Plugging a 0 in gives us 2 times 1/3 to the 0 power would just be 1, and 2 times 1 would be 2. Plugging a 1 in, 1/3 to the first power would just be 1/3. 2 times 1/3 would be 2/3. And the last point, x equals 2. 1/3 squared, square each of the numbers and you get 1/9. 2 times 1/9 would be 2/9. Graphing this function, again you can draw the xy axis. On the y value we'll go up to 18. And we'll have a couple points in the x and y direction. First point, negative 2, 18. And negative 1, 6. 0, 2. 1, 2/3 will be close to the x-axis. And 2 2/9 will be close also. Connecting them again, we'll have a curve going through the 5 points. Again, it will go parallel to the x-axis, and off to the left it keeps rising up. The difference on this graph is if you have a fraction as the base being raised to the exponent, it curves down to the right. If we had a whole number like we had 2 before, then it curves up to the right. The next section of notes is titled Write an exponential function. In this section we'll take 2 points and find the equation for the exponential function. The definition or equation we'll use for this section is y equals a parentheses b to the x power. All exponential functions are in this form where a and b can be any coefficients. The first problem will have 2 points, 0, 7 and 2, 63. Again, using these 2 points, we want to find an equation, an exponential function that passes through both of these points. What we'll do first is take our equation, and the first point, 0, 7, we'll plug those in for x and y. Y is equal to 7. A and b will leave as variables, and x is equal to 0. When you plug a 0 in for x, b to the 0 power is equal to 1, or it cancels out, and we have a is equal to 7. Once you know the value of a, then you can go back and take that same equation, and now we'll plug in the second points for x and y, and we'll also plug in a value for a. So using the second point, y is equal to 63, a we found was 7, b we'll solve for right now, and x is equal to 2. First step to solve for b is we can divide by 7. 63 divided by 7 would be 9. So b squared is equal to 9, or b is equal to 3. We'll take the positive square root. For exponential functions, b always has to be a positive number. If it's negative, then it's no longer exponential. But our final answer, y equals a, which is 7, b, which is 3, to the x power. So using 2 points, 0, 7, and 263, we can find the exponential function. Last section of notes today is titled Solving Exponential Equations. First equation we'll solve is 3 to the exponent of 2n plus 1 equals 27. Exponential equations will have variables in the exponents. To solve these, we want the bases, right now they're 3 and 27, to be the same on each side. What we can do for this problem is 3 to the 2n plus 1 stays the same, but 27 we can change so it has a base of 3. And that would change to 3 to the third power. Once the bases are equal, you can cross those off or ignore those, and then we'll set the exponents equal to each other. 2n plus 1 equals 3. Solving this, you can subtract 1 from both sides, divide, and you have your answer n equals 1. The next problem we'll solve is 16 to the exponent of n is less than 8 to the exponent of n plus 1. This time we have variables on both sides, and we also have an inequality rather than an equal sign. Same steps, we want to change these bases on both sides to be the same number. In order to do that, we'll have to change each base to a different number. For example, the 16 you can rewrite as 2 to the fourth power, and the n would come down. 8 you can rewrite as 2 to the third power. Since we have a binomial exponent n plus 1, we'll put that in parentheses so the 3 will be distributed to each of those. And again, once your bases are the same, both are 2's, you can cross those off and ignore those, and we'll set the exponents, in this case, less than each other. 4n is less than. The 3 we can distribute out, which would be 3n plus 3. And solving gets us the answer of n is less than 3. Last question we'll do for this section is 1 over 9 to the exponent of m equals 81 to the exponent of m plus 4. And again, we want to match up the bases on each side to have them be the same base. In this case, when we have a fraction 1 over 9, we can rewrite that as 9 to the negative 1 power. The m would come down, so it would be negative 1m. 81 we can rewrite as 9 squared. And again, when you have a binomial exponent, we can put that in parentheses, so when we solve it, it'll get distributed out. The 9's again are equal, and we have negative 1m equals 2m plus 8. We can subtract 2m from both sides and divide to get our answer. M is equal to negative 8/3.